So this video will be most helpful for ShortestRoute if you start by going to my website and taking a look at the PDF description, and then you download the files. Make sure you also have OpenFile and STD Draw. You'll need those, and then you compile and run insert at nearest. That has main in it. So do that first. Make sure you read the directions, etc., and then this is going to be helpful. I want to talk about the nearest neighbor algorithm or heuristic. So we're going to do some drawing on the whiteboard here. So this has to do with us picking some points. So the nearest neighbor, we're just going to start with some random points. So I'm just going to draw some random points on the screen. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we'll start with 9. It looks like some of these are kind of extra points, but that's okay. And then we're going to number them. So we'll maybe call this one 1, and then this one will be 2, and then this one will be 3. Ooh. And then this will be 4, maybe. How about that's 4? And then that's 5, and 6, and 7, and 8, and 9. Okay, so I'm just kind of simulating what you're going to see in the text file, right? You're just going to have points that are in the text file, and you're not going to be able to choose the order. They're just 1, 2, 3, 4, and you have to deal with them as they come. And so let me talk about the nearest neighbor idea. So let's say, so we pick up the first point, and there's no choice when you are creating your set of linked lists. You're going to take this point, which is the first point, and you're going to put it in the object place for the list node, and that'll be the first list node, and you start there, and then you pick up the second point, and there's no choice but to link that to that, right? That's how it's going to start. Okay, and then when you get to the third one, you're going to start making some decisions. So you get to the third point, and you're going to find the nearest neighbor. So the nearest neighbor is going to be the 2, it looks like. And so I'm going to connect those 2. I'm going to link the list node there that has that object, the point, to this object. So far, so good. And then I pick up the 4th. Now, I look at the 4th point, and I want to see the one that is closest. It's kind of a toss-up. I'm going to say that it's closer to the 1. It might be closer to the 2. I'm going to say it's closer to the 1. A little measuring with my fingers here. Yeah, I'm going to say it's closer to the 1. So with the nearest neighbor heuristic, what you're going to do is you're going to delete. You're going to place that point. This is the 4th point, and you're going to insert it after the point that it is nearest to. So I'm going to delete this line, and now I'm going to link the 1st to the 4th, and then I'm going to link the 4th to the 2nd. So you find the point that it's nearest to, and then you are always going to insert it after that nearest point. Okay, so now we pick up the 5th. It's nearest to the 2nd, and so we want to make sure that we link it after the 2nd. Now keep in mind that this heuristic or algorithm is not necessarily going to lead to a shortest path. So we're going to erase. So we have to link it after the 2nd. So we have to remove that link there. And now we're going to draw a line from 2 to 5, and then relink this from 5 to 3. And let me just repeat, this nearest neighbor algorithm or heuristic isn't necessarily going to give you the best algorithm, the best path. Okay, it looks like 6, that's closest to the 3, so that one's easy. We're just going to link it after the 3. And then the 7th, again, that one looks like it's easy. It's going to be it's closest to the 6, so we're going to link it after 6. Okay, and now the 8, looks like the 8 to me is closest to the 4. So we're going to insert it after the 4. So I'm going to need to delete this line and then link it here. 4 to the 8. And then I'm going to want to delete 8 to the 2. Okay, so far so good. All right, one more to pick up. So the 9, it looks to me like the 9 is closest to the 2. Now, just a reminder that this heuristic is not necessarily going to give us the best path. So we have to make sure that the 9 is linked after the 2. So we're going to delete that. Whoops. Let's do that. Try that again. Okay, there we go. And then we're going to draw the line. 2, and then we're going to relink 5. And there we go. That's our path using that nearest neighbor heuristic. Now, the understanding is that wherever it's going to start here, always with whatever the first point was, and then you're going to have a last point, and then the last step to take would be to connect these two. Maybe I'll do it in a different color, red, to show that it's kind of special. But it does have to be a circuit that you're creating. And this is certainly not the best path that we have created, but it's a start. And that is the general idea. All right, so let me show you some running code. So I'm going to be giving you the starter code, right? So let's go into the starter code. Oops. Starter set. And I give you some code. So it's Java C insert at nearest Java insert at nearest, and you need to give it a text file. So I'm going to do p20.txt. That's one of the files, and it picks them up, spits them out, so it spits out the points, and then it gives you a route. Now, I haven't written the code. You haven't written the code yet to connect them. The length is going to be the length of the total route that you're going to create, but that's what it should look like if you give it a valid text file. It's just going to spit out the points. You haven't dealt with them yet, but that's what your starter code should look like. Let me show you what this is going to look like once you have it finished. So we'll say Java insert at smallest, and I'm going to give it p20.txt. Oh, sorry, insert at nearest, not at smallest. There we go. Now you can actually see mine being built. Now when you turn yours in, you're not going to be showing the change in the screen as it goes, but you should just do the work in the background and then show it. But as you're debugging, you might want to do this. It might be more instructive if I do P with 100, so 100 points. And you can see it being built here. Again, obviously not the shortest route. And then I don't know if I'll let P1000 run the full time, but you can see it being built. Now again, when you're done with your code, I don't want you to show all of the steps as it's being built. I want it just to do the building in the background, and then you should show it at the very end. And that's the work. Okay, now I think it's going to be around 27,000, so maybe I'll wait until that's done. Then we'll take a quick peek at the code, and then you'll be on your way. And then once everything is said and done here, it spits everything out to the screen, tells the points in the order that they wind up traversing, and then the length, number of points, etc. Okay, let's go to my website and take a quick look at the code. Of course, you're going to want to read the directions. I've given you a point class that you don't need to change, right? And the objects in the list node are going to be points. Those are you're connecting the list nodes, connecting point to point. And then we've got the shortest route. We take a quick look at this code. So you're going to be writing this insert point at nearest neighbor, and that's going to be called by your insert at nearest. And this is drawing the node, drawing from one point to another. And then let's look at main. So main is here. And so what you're doing is you're opening up a text file. There's a default text file that it'll open up, but you want to give it a command line argument. And then it opens it up, and then it's going to call that method insert point at nearest neighbor. So this class is pretty much done for you. You might change some things as you're debugging, but it's pretty much done. And then the code you write, remember you're actually creating a singly linked list. That's what ShortestRoute is. It's a singly linked list, and you are going to get that done. We're going to take probably a week and a half, maybe a week and a half to work on this. We'll kind of evaluate as we go. All right. So I will be talking to you. Remember, you can always check in at tutorial, check in for our weekly meeting, and I'll probably give an update video on this a little bit later in the week. Bye.